everyone. So welcome to the monthly community meeting of WasmEdge this month. Again, my name is Michael, and well, first of all, I really appreciate our colleagues in Asia to be able to join us tonight. And I know there's lots of activities going on there, but let's focus on the technology. And there has been a lot of going on with WasmEdge in the past months. We released a new version, and we have some really exciting development in terms of having more developer tools and libraries. And in fact, we just released our new version of Rust binding today. So so there's lots of activities and news around developer support. So so the agenda of this talk would be let's start it with a brief overview of what's going on with the new version of WasmEdge 0.10.1. So is Hydai here?
Yes.
Yes. Okay. So Hydai, please. Yeah.
Okay. Can you see my screen? Okay, so let's get it started. And today I'm going to do the 0.10.1 review of our, the WasmEdge release. So first of all, in this version we suppose I think we suppose 3 new proposals. So the first one is that the WasI neural network plugin. So now you can use the OpenMiddle to load your AI model and do some image inference with this proposal. And if you want to, build this support on your environment, please use the Ubuntu 20.04. This is, I think this is required by the OpenVINO, I think, because the pre-built version of the OpenVINO is based on this. And of course, you can, build the OpenVINO library on your own environment. That's fine. And please make sure when you want to enable this feature, and you will need to, add a CMake flag to enable this backend. Also, we have support the WasEquipment plugin on not only the x86 environment, but also on the ARM machine. So now you can, write your application with some WasEquipment functions. For example, you may want to generate a key pair and want to encrypt or decrypt some string. Okay, and currently we are based on the OpenSSL 1.1. In the I believe maybe in the end of this year, we will upgrade this version to the OpenSSL 3. Also, if you want to, use this feature, please make sure that you add this flag when you build the WasmEdge. And we also support the WasmEdge proposal. So you can use the WasmEdge proposal threads in the configuration to leverage this feature with our C library. Or also you can use, enable threads to run your application with WasmEdge thread proposal in WasmEdge and WasmEdge C. Okay, so we deliver 3 new proposals in this version, and we have, according to the developer requirements, so we export 3 new member from our VM. So now you can get the loader, get the validator, and get the executor from our virtual machine context. Also, we refactor our tools. So now you can find that our WasmEdge runtime and our WasmEdge compiler is referred to the WasmEdge library, which is in this namespace called driver. So if you want to, use this directly, you can call the WasmEdge driver compiler or the WasmEdge driver tool from our C API. And then we have a special built-in options, which is that allow you to try to build the WasmEdge in static linked mode.
Yeah.
Okay. So, and the next thing is that the default LLVM version is bumped from the 13 to 14 on the Mac OS. So we support this new version, and currently our release is based on the Mac OS 11 because that's the GitHub overflow have dropped the 10.15 support. So there still have some no issues. We are trying to fix them. So the first thing is that our plugin system will fail on the Mac OS still in this version, and we are trying to to refine the implementation of the plugin system to make sure that the Mac OS can use our plugin system. So we already redesigned the plugin system from the C++ API to the C API. And this should be shipped in the next release. So we hope we can fix it as soon as possible. And also, if you run the WasmEdge CLI on the Windows 10, you may encounter a special error called some dynamic library is not found. And if you encounter this error, please go to the Microsoft website and try to download this file. Yeah. So after this release, we are planning to have a new release at the end of this month, which is the 0.11. And in this version, we will do some breaking changes. So the first thing is that we hope we can have more and more backends in the WasI neural network proposal. So in this version, we will enable the PyTorch backend with the WasNN proposal, and also if you download our old version and you install the LLVM from the latest brew library, you will find that actually our previous build is based on the LLVM 13. However, now you can install by default is 14. So there will be some link issue. So we are trying to link the LLVM, just use the static link into our tool to make sure that this error will not occur again. And we will do 2 API breaking changes. So the first thing is that in our previous version, our host function interface can only access the memory instance. However, if the host function want to call a Wasm function, there is no way in our current design, because the Wasm function table is stored in this store manager. So we want to export more and more component to the host function level, so the developers can leverage all of the functions they want. And the final thing is that we will support the user-defined error code on the host function. Because in the current design, actually, whenever your host function return or report the error code, we will only ship that the WasmEdge runtime is execution failed, and report with our own error code. So there is no way for the developers to propagate their error code for I believe is for the debugging purpose. So to fix this, that we will do these breaking changes. So now in the next release, the developers can can report any error code they want. Okay, so there's our big focus on the next release. And at the end of this slide, I want to give the special thanks for these contributors. With these guys, so we can ship this version. So big thanks to these people. And that's all of my slide. Thank you.
All right, thank you, Hydai. Yeah, that's I think a lot of people are really interested in WasmEdge and WasmEdge crypto and thread. Those features that you mentioned earlier on in the talk. I think we are having a series of conference talks and tutorials around that area. That's I think we are going to VMware Explore at the end of August, and also in a bunch of I think in several what's that conference called? It's called Developer World. That's both in Portland and also in Austin. I think later this quarter, and also we have several talks accepted in that area in KubeCon. That's in Detroit in I think October this year. So we are looking forward to talking about those issues and having tutorials and demonstrations. I think those the WasmEdge is especially interesting to a lot of people in the edge computing community, and also the WasmEdge crypto stuff is also critically important to us, because one of the things we want to do is to make WasmEdge a fully fledged runtime for microservices, and in order to do that, we already support HTTP and socket connections, so you can run a server inside WasmEdge and then run the microservice, right? And have SDKs connecting with sidecars and other service mesh stuff. And however, one of the missing piece here is HTTPS, because in order to have a modern microservice, you really do need, in order to consume other services, for instance, if you want to call the GitHub API, you definitely need HTTPS. And we now, I think as of today, we do have a solution for HTTPS. However, it's not, I think it's halfway. It's using blocking I/O. It doesn't have support for asynchronous I/O. So so extension of this topic would leads us to our next talk. From Trister, from GitHub. That's what he has done, what our team, what the community team has done is to port the asynchronous runtime in Rust, Tokio, into WasmEdge. Why do we need to do that? Because if you just compile Tokio to Wasm, you would not be able to run it, because the runtime requires multi-thread and things like that. And but we have successfully tested and ported aspect of the Tokio into WasmEdge, and then allows it to run fully asynchronous networking applications using standard or nearly standard Rust APIs and Rust tools. So without further ado, let's hear our next topic, the asynchronous runtimes in WasmEdge. Please.
Okay, let me share my screen first.
All right.
Hi, everyone. The topic of my talk is running Tokio applications in WebAssembly. First, I want to introduce why we need async. For blocking I/O, we have to wait for the I/O operation to complete before we can perform subsequent computations. If our task is I/O bound, we'll spend a lot of time just waiting, such as waiting for a response from the server. Well, asynchronous programming enables us to run multiple I/O operations at the same time without wasting any time waiting, because we are using non-blocking I/O instead. We can just start an I/O operation and do something else. When the operation is done, we'll be notified. In async Rust, the most important concept is the future trait, which is basically a task. The main function is a big future, and during execution, more tasks will be created. In Rust, a future will only be executed if it is polled. But here's the question: who will poll the futures? That means we need an async runtime. An async runtime takes the responsibility to poll futures. Takes the Tokio runtime as an example. Normally, we use Tokio main to wrap our main function like this. It's just a procedural macro which transforms the main function to the right one. First, we create a Tokio runtime instance, and then we block on the main future. In the main future, we can do what we want, such as reading a file or performing network requests. A common design pattern we use to implement an async runtime is the reactor pattern. In short, when performing the I/O operation, we'll register the I/O source onto the reactor. And when the I/O operation finishes, the reactor will be notified and send this task to the executor. The executor will poll the tasks one by one. Well, WebAssembly is single-threaded for now. For simplicity, we can just use a queue to store incoming tasks. And every time we pick the front task to execute until there's no more tasks. Note that during execution, tasks can append new tasks into the queue. So this is our executor. Next, we need a reactor. WasmEdge provides us an interface called pull1off to interact with other non-blocking I/O libraries like epoll. With the help of this, we can just wait when there's no task to execute. And once the task is ready to execute, we'll be notified. We implement a naive runtime called WasmEdge async. The link is on the slides. And it's a good example showing how to implement an async runtime for WebAssembly, but not suitable for production. So we need to port Tokio to WebAssembly. As for Tokio, we follow a similar pattern. We need to modify the executor and the reactor. First, let's deal with the reactor, mile, which is an abstract layer of non-blocking I/O libraries. It supports many operating systems, and we need to add WasmEdge into it. We need to do two things. First, we need to add network functions for WasmEdge. Currently, most of the network functions in standard libraries for WasmEdge are empty. So we use a crate called WasmEdge WasmEdge socket, which implements common network functions in WasmEdge. Next, we add the pull1off function following the interface defined by mile. After that, we have WasmEdge support for mile. Let's take a look at the executor Tokio. Tokio is a multi-threaded runtime, and we can only use the single-threaded mode of Tokio for now. In addition, we replaced the network component in Tokio with WasmEdge WasmEdge socket mentioned above. Afterward, it works. We can run async application in WebAssembly with Tokio. Next, I will show you two demos of using Tokio in WebAssembly. One is the mini Redis, which is a educational project by Tokio, and the other is Hyper, which is an HTTP library in the Tokyo ecosystem. Let me change my screen to the demo. So let's first take a look at the mini Redis. So we need to set up a mini Redis server first. As you can see, we first compile the source code to WebAssembly and use WasmEdge to execute the generated file. And next, we can use simple commands to interact with the server. Like here, we set a key foo to a value WasmEdge, and the same, we need to compile the source code to WebAssembly first and use WasmEdge to execute it. And as you can see, it returns OK for us. And next, we can try to get the result we set like this. And we can get the value we set last step. And next, let's take a look at the Hyper demo. Hyper is kind of like a HTTP library. So we can first send HTTP request. Like here, I send it to a website. And the same, we need to compile the source code and run it using WasmEdge. And as you can see, we can get our response from the web server. And at the same time, Hyper can be used as a HTTP server. So we can set up a server like the simplest server is the Echo server. And now we set up a server listening on the port 3000. And we can send a request to the local host. And after that, we get a message from the local host, and it said we can post some data to the path echo using the following command. And if we follow that, we do the same thing, and we get the data we send to the server. And here is hello world. We can change it to something else, like we can change it to maybe WasmEdge, and we can get the same response as a request. And this is two demos I'll show you. Let's change back to the in the end, I want to talk a little bit more about the future of the async WebAssembly. One good thing is to have threads in WebAssembly, which is proposed already, and we already have it in WasmEdge. Once we have threads in WebAssembly, the performance of the async runtime will improve. On the other hand, we are also investigating some possibilities of executing WebAssembly programs asynchronously. For example, we can pause a WebAssembly program when it's not ready, like waiting for some response from the server. And once it gets the response, we can resume the program. And basically, for now, we are compiling the whole Tokio program into one single WebAssembly program. And we are trying to investigate the possibility of running applications in Tokio, which use Tokio as a host system to run multiple WebAssembly files asynchronously. That will benefit for the industry. And that's all my talk today. Thank you for having me.
All right, thank you, Trister. Yeah, that's I think that's a very, very interesting topic, because this is something very unique to WasmEdge. So there's if I may comment on that, there's at least two aspects of it. One is to run Tokio applications as guest applications inside WasmEdge, and as you can see, that we can do it. We already can do it now. And now there's lots of networking applications or microservices that's built on the Tokio library. So, for instance, in our GitHub issues, you can find support for MySQL drivers, support for various cloud-based databases and other databases. Those are all, the client or driver of those applications are all, at least in the Rust version, are already in Tokio. So, so at this moment, we can just compile them and see if they run. And then there's a whole other array of microservices, that's that also, web services. So for instance, the Kubernetes SDK, the Dapper SDK, there's the GitHub SDK, there's lots of them that's also developed on Rust based on Tokio, and with supporting Tokio inside the WasmEdge runtime, I think there's a real possibility that that we would be able to accommodate this entire ecosystem of web services and the microservices. So that's one aspect of it. It's running Tokio inside WebAssembly or inside WasmEdge. Of course, there are people who ask me, so the way that we run Tokio, like Trister said, is based on single thread scheduler. If you really want to do a server-side application, don't you need multi-thread? The answer really is no, because if you look at Node.js, the JavaScript runtime is single-threaded, right? So it's there are lots of things you can do, and it has proven scalable to do to have a single-threaded runtime, has multiple single-threaded runtimes that handle those web requests. So that's one aspect. And then the second aspect of it really is that is not unique to WasmEdge, but I think very few Wasm runtimes in the market that can do this now is to integrate into a host Tokio application. So meaning that you have a host application that embed Wasm. Instead of have an application running inside Wasm, you have a host application that embed Wasm. And this host application is asynchronous. That requires the Wasm runtime to be asynchronous, meaning that it would be able to pause the application that's currently running inside Wasm and resume it later. It would need to be able to save the states and do things like that. In this market, I think WasmTime is one of the early pioneers here. But if you look at WasmTime's implementation, there's a WASI spec out there. It's called Stack Exchange or Stack. That's whatever it's called. But if you look at their implementation, there's guess what? There's a lot of assembly language code in there. To support that in a cross-platform manner, right? That's because you have to manipulate memory directly, to pause a Wasm application and resume it from the point where it paused, right? And then there's another school of approach, which is called Asyncify. That is the project at Wasm OPT. It's basically instrument Wasm code to add additional functions that to save and reload the state. And that's we thought that approach is probably going to be easier to a lot of developers. That's and also easier to make it happen in a cross-platform manner. So I'm just talking about what to look forward to. That's so we also have so we are also actively working on Asyncify support, and you can see that from our GitHub issues as well. It's to have basically to have a Wasm application, and then using Asyncify, which is I think either use their version or use our version. That's we call it WasmEdge Asyncify. And to instrument it, and then run the instrumented application inside asynchronous host application. I think that opens the door for a lot more use cases for WasmEdge, because if you look at how WebAssembly is used in the cloud environment, a lot of those are embedded use cases, and the ability to do it asynchronously is very important to us, right? So this is something that's that we're going to support the Rust-based host first, with because a lot of our work is around Rust. However, I think in the future we would also support the Go-based host as well. Meaning that from a Go-based host applications, we would be able to start, pause, and resume WasmEdge applications that are embedded in there. So I really look forward to towards those very fundamental enhancements to the WebAssembly community that we have been trying to do in the WasmEdge community. And so yeah, that's with all those things going on, and if you have we are constantly looking for contributors, not only people who can help us design, and also review the current approach, but also people who can test the work we have done, because we have made changes to other infrastructure projects, like what Trister has just shown. We have made changes to the Tokio runtime, so that make it more compatible, make it compatible with WasmEdge, right? To port it to other projects, to have, say, other Tokio-based applications running on this forked or changed version of Tokio, or help us try to merge it back to the upstream Tokio, right? So there's lots of things that we are looking for contributors and people to help out. So if you're interested, or if you have spare time, we'd love to have you guys here. Okay, yeah. So I think we are a little bit earlier today. That's we have about 20 minutes left. So if anyone wants to ask a question, or you can speak directly, unmute yourself and speak directly, or you can type in the chat message. That's we're going to be here, and until there's no questions. So yeah.
I've got a quick question, Michael. It's Brad Jones.
Hi, Brad. Yeah.
Yeah, I missed this because I had, of course, trying to multitask at the same time, but perhaps I missed the in the Tokyo talk there. What was the timeline like? Is this going to be part of the 11.0 release, or just shortly thereafter? Do you have an idea?
It'd be so there's two aspects of Tokyo. I think both of them would be released before the 11.0, because 11.0 WasmEdge release is primarily focused on because we need to support a bunch of API changes on the C API level. That's
Sure.
But in terms of Tokyo support, it actually doesn't require those API changes. So for running Tokyo as a guest application, as Trister has demonstrated, you can do it today. You can actually run the Tokyo mini Redis, which is a fairly complex application, entirely inside WasmEdge. So that's already done. And one of the big missing pieces here today, as for practical use, is HTTPS support, which goes back to the WASI crypto stuff, right? So we can do HTTP and TCP/IP with no problem, but with HTTPS, there's more work that needs to be done. So that's Tokyo as a guest. Tokyo as a host, that's I think we are still a couple weeks away. I would think, maybe hopefully, I think by our meeting next time, next monthly meeting, we would we definitely should have something to demo, a working demo for
that's more than sufficient. That's great. Very exciting. I really think that's brilliant strategy. This is great.
Yeah, that's we also love to at a time when it's convenient to you, to understand what how you have been using it, right? And how we can support that. Yeah.
We have not yet had a chance to, but I'm just the timing is getting so close, and this will be great. So converging in the next 30 days is just going to be great. This is good stuff. This is great. I'm really excited. Congratulations to you and the team. Good stuff.
Thank you. Thank you. So all right. So if there's no more questions, I think maybe we can finish this meeting a little earlier, so everyone can can go to sleep or go to lunch, depending on where you are. And yeah, that's you know how to find us. You have my email, my GitHub repository, and you have all those GitHub issues I mentioned in the that talking about Tokio support, talking about those new plugins, new installers, and things like that. And yeah, that's so okay. Where's GitHub repo? Let me put it here. There we go. Okay, all right. So thank you, everybody, and you have a good day. And I think that's let's finish a little early today. Thanks. Yeah.